Okay, today we're talking about the definition of a derivative. In calculus, there's basically two halves. The integral, which is the area under a curve, and the derivative, which is the slope of a line at a particular point along that line. For the integral, you just basically length times width is what you need to know. The derivative is rise over run. A big part of it anyway, that's where it comes from. Let's say you have a point here and a point here. Connect it with 2 points, and let's say this is 3, say this is 5, and over here, I don't know, we can call that 5, and I'll call that 7. Rise over run. The coordinates here would be 3 and 5. The coordinates at this point would be 5 and 7. To get the rise over run, this is how much it rises, and it goes from 7 to 5, so it's 7 minus 5, over the run, which is 5 minus 3, which equals 2 over 2, or 1. Using that basic concept, we can get the definition of a derivative. Now, the derivative looks a little more confusing, but it's the same concept. Let's say we have a line that goes like that, and we want the slope at a point, say, right here. That can be any point along the x-axis here, so we'll just call it x. Now, the corresponding y value over here would be evaluated as f of x. So the point right there would be x, comma, f of x. Now what we're going to do is to approximate that, we'll take another point along the line, say right here, and we'll say that's a distance h away from the x, which means this point here would be x plus h. And the corresponding value along the y-axis would be f of x plus h. So now we have a point over here. And this point would be x plus h, comma, f of x plus h. Now we're going to evaluate it the same way we did the simple linear line. Basically, rise over run. How much does it go up over how much does it go over? So to get how much it goes up, we're taking f of x plus h minus f of x. Over how much it goes over, that'd be x plus h minus x. That's the slope of the line that connects these 2 points right here. Now to get the derivative, keep letting x be smaller and smaller. As we do, this point will go back towards the point we're trying to evaluate, and the approximation will get better and better. So for the derivative, what we'll do is we'll take the limit as h approaches 0. Now you can see here, you have an x and a minus x, so those are going to cancel. We take the limit as h approaches 0 of f of x plus h minus f of x over h. And that right there is your basic definition of a derivative. Now for example, we can take, let's say f of x is equal to x squared. In that case, f prime of x, which is the notation for the first derivative, would be the limit as h approaches 0 of f of x plus h. So we have x plus h, so we'll plug x plus h in anywhere we see an x. So x plus h squared minus f of x, which in this case is x squared, all over h. Next line here, limit as h approaches 0. To evaluate that, first term squared plus double the product plus last term squared, and then we still have the minus x squared here, all over h. Limit as h approaches 0. We have x squared here and an x squared there. That cancels out. We're left with 2xh plus h squared over h. Got a common factor here of h, so we can cancel that out. We get rid of it here, here, and there's two h's here. Get rid of one of those. So we have the limit as h approaches 0 of 2x plus h. And when h goes to 0, we find that the first derivative is in fact equal to 2x. Now we started out with this x squared, and basically in general, if f of x equals x to the n, and n is a positive integer, then f prime of x is equal to n times x raised to the n minus 1. There's the basic definition of a derivative, and just a simple matter of rise over run.